Welcome to Akhand Vidyashram, the first institute of impeccable wisdom, the divine nerve action potential. Divyank, the walking, talking encyclopedia. My mission, the impeccable wisdom, knowing which everything is fully known. My greatest discovery, Divyank, the divine design of nature with which the perfect objects are designed and created. Divyank is the reward of 60 years of integrated education. Now let's understand nerve action potential as we understand from different books and others. Now, at the outset, let me put it on record this particular picture as the sequence of events which take place in action potential is very, very good. So that way, this representation by the Cambridge University, I appreciate and do that. And this is much better than presentations which are available in books, journals, articles, internet, and otherwise. So let me take it that this particular presentation is standard as far as the sequence are concerned. Only thing which I would like to highlight in the light of Divyank, certain areas which have been taken for granted that we understand, and I'm going to explicitly explain those things only. What really happens in physiologically. Okay, from that let's understand nerve action potential. I think in the beginning itself I have told you the last Nernst equation is used to find equilibrium potential or resting membrane potential. I'll show that particular slide again, but in that we had used the log of minus 61, and I say log of minus 61.8034 would have given a better or perfect equilibrium potential or resting membrane potential. Anyway, in case of nerves, resting membrane potential of minus 70 is pretty good. Let us accept that this is a standard good value. Okay, now from that, when we apply a stimulus, it could be normally they say there are three kinds of stimulus: mechanical, chemical, as well as electrical. But I do know the psychological stimulus can be equally powerful. So for me, there are four different kinds of stimuli: mechanical, chemical, electrical, and psychological. So one of the stimuli which is applied, and normally here could be a mechanical, if every stimulus also has a threshold value, that means it's powerful enough to convert resting membrane potential to take it to threshold value of minus 55 millivolts. And thus any stimulus of that power which can bring resting membrane to threshold value of minus 55 is called threshold. If any stimulus which is less than that is applied, sub-threshold stimulus is applied, you can only form local graded potential, and this is useful in a local areas where the signals do not have to go. As in sparsh or the touch, divine touch, I said, any touch should go to the brain for perception. That means from receptors to the nerves, the 10 stages of nerves, and then to the central nervous system in the spinal cord and the brain, through ascending tract to thalamus and to the sensory cortex or maybe parietal, and perception takes place. That is threshold. Sub-threshold will be in GIT and local things which are also essential for hormone release or this. They don't have to have a very powerful. So those are called local graded potentials, and it's localized, and that value will be less than that. But threshold, when it reaches a particular level of threshold, as you can see in this plot between 70 to 55, they show a curved line. But when it reaches 55, then you find suddenly a peak going up. Why? And as in this picture says, the number of voltage gated sodium channels open. As a result, you see depolarization. But after a particular stage, it says the voltage gated channels start to close. As a result, it comes to one particular value called plus 30 millivolts. At that particular juncture, sodium had closed, voltage gated potassium channels open. That means as earlier sodium was going inside, sodium influx, now you have a potassium efflux, means potassium inside the neuron cells, cytoplasm of the neuron cell starts coming out. But remember, sodium remains as such, only potassium is coming. And now it says voltage gated potassium channels start to close at a particular stage during repolarization state. But it comes to hyperpolarization stage and then comes to resting membrane potential again. So now missing areas here. Have we missed something which is responsible between minus 70 millivolts to 55 millivolts between threshold value? That's one area. What happens during that period is sodium potassium channels when they close. Is that enough? That only potassium moves out and you can get hyperpolarized state. That's also a big question mark which has not been dealt or reflected upon. I'm not finding fault, but I'm just trying to say simplification, oversimplification is not size. Sequence should be perfect so that people can understand logically, so that no more question run to their mind whether it's perfect or not perfect. As I had the problem in trying to explain to my students when I started teaching in medical college. Now I can understand that I do not want that problem with the rest of the students who are just starting to learn there. So from that point of view, I think this picture is very clear. You have resting membrane potential, you could have local graded potentials, or you can go for action potential. Sodium influx, then potassium efflux, and then this. So there are gray areas which we'll explain in the last slide which I given. At this juncture, keep this particular picture in mind. I'm going to use the same picture to fill in the gaps or find lacunae and fill in the gaps. Now, this was the topic for the last video, which is Nernst equation to find equilibrium potential and resting membrane potential. As I told you, log of 61 was used, and I would say log of 61.8034 will be more. But in this particular picture, I've also brought another picture down, which is the representation of sodium potassium ATP pump. And in that you can see for 3 ions of sodium from inside the cell, when they move out, only 2 potassiums can go inside. At this juncture, I just want you to remember, for 3 sodium ions from inside the neuron cells, which move out, only 2 ions of potassium can go in with the help of ATP. And this sodium potassium pump is something which was missing in that particular thing. What is its role? We will talk. But as far as 2 and 3 is again Divyank ratio. Please keep that in mind. So we are coming to Divyank, the divine design. Everything is designed with that. If you keep that in mind, understand Divyank ratio, Divyank sequence, our understanding of the perfect human anatomy, physiology, biochemistry will be much more simpler. And that is why I'm emphasizing again and again. Let's understand this concept and then see its application in nature to make it an impeccable wisdom. The most important terms I did speak about earlier also. Resting membrane potential is threshold value after polarization means both resting membrane, a polarized state, you have a negative charge inside and positive charge outside. You can see in the picture of the node of Renvier between 2 myelin sheaths. And depolarization is the state when you have a positive charge inside also. But although this is again shown negative outside, but overall extracellular fluid will not become negative. This negative charge is just surrounding the axon, not extracellular fluid again. This is also something which I would like to explain to the people, that this charge which a representation is around the cell membrane without taking into consideration the charge of the extracellular, intracellular by and large. That also one point which I like to highlight. This is the reality. Now, supersaturation is the term which I brought because when they say a plus 30 is a stage, it's because supersaturation of sodium ions. No more sodium can go inside. It's supersaturated. It has to stop the sodium channels and open up potassium channel because supersaturation inside, because amount of electrolytes which can go inside the nerve or any cell, there is a limit again. Understanding of these concentrations which is possible, Divyank sequence helps you to do that. And repolarization is again, you come back to resting membrane potential, the charge coming closer to that. Hyperpolarized is nothing but resting membrane potential instead of 70, reducing it to further 72, minus 72, 73, or maybe 80 also. So I think these terms are very clear, and the picture of neuron cell and then 10 parts in the middle. I'm sure you remember what are the 10 parts of neuron cell, from receptors on the left side to the end, with which they form a union with another axon or maybe muscle, which we'll be talking in the next video. But picture on top is the same thing, just replications as you understand. This is, and resting membrane potential of skeletal muscles is minus 90, neurons is minus 70, smooth muscle is minus 60, photoreceptors in the eyes minus 40, erythrocyte RBC, red blood cells is minus 8.47, and chondrocyte is 8. Now, why you have more in skeletal muscles, less in neurons, and very less in RBC? Is again amount of electrons present is different. Anyway, let's not go into detail at this second because that is not, but I want to literally explain one more concept. You can see axon, then you see myelin sheath, which is myelinated Schwann cells. In the last video I had told about the Schwann cells which are there between, the full axon is covered by that, but between the two axon cells are their myelin sheaths. At myelin sheath again, Schwann cells have got lipid layer around, which is almost like 10 rounds again. It's also surprising, but as a result, no charge can take place there. But nodes of Ranvier are unmyelinated. There's no myelination. As a result, sodium from surrounding extracellular fluid can get inside the axons. So I think that is something which I would like to bring it. This picture as I brought it, so your understanding of saltatory conduction responsible for the travel of signal from receptor end to the other end, because it cannot go in one shot. See, suppose something is in the leg, it has to reach brain. You need to reinforce it at every stage, like what you do in what is a TV signal you call it, or a phone signal you call it. You have to have a pump at every stage, and this exactly nature also does the same thing. Longer the distance, the more and more areas where you need to have boosters to take it further. So the nodes of Ranvier act as boosters where saltatory conduction takes place and signal is carried to this. And saltatory conduction is nothing but exchange of sodium and potassium ions, which are important. Okay, from that point of view, now let's go to the next stage to understand the concept very clearly. We come back to the same picture. Now, in light of Divyank, we are going to understand this concept even better. Let's start minus 70 millivolt to minus 55 millivolt, there is a gradual curve, and that curve is due to influx of sodium ions from extracellular fluid, intracellular fluid, and intraneuronal fluid is a slow channel, open channels. Please keep it in mind, it's open channel, slow influx of sodium ions. As a result, it is gradual. And that the way this goes is also a representation of Divyank ratio only. Let's not confuse ourselves at this stage and leave it at that. Now, next, when it reaches the threshold value, after slow influx of sodium ions leading to this gradual thing, then voltage gated sodium channels open up. And as a result, immediately there is an influx of immense amount of sodium ions inside. And that leads to peak or depolarizations. Immediately, like a shot it goes. But here I would like to say sodium and both are important, but sodium is more electrogenic than potassium. What could be the reason? This is also something very interesting which I tell my students. Look at the nature design, how it is. Now, my explanation to them is number of protons and neutrons in sodium is much lesser than number of protons and neutrons in potassium. Imagine a lorry carrying lesser load and the lorry carrying higher extra load, which will run faster. I'm sure from observation and common sense, you will always say the one which has less load can go faster than the one which carry heavy load. So similarly here again, sodium protons and neutrons are less than the potassium. As a result, it can go faster, and that's a more electrogenic position. But incidentally, you might be a little surprised, the ratio between the sodium and potassium is also Divyank, 11 versus 17. Is it a coincidence or is it divine design? These are the things which make any subject interesting. You remember entertaining movies or songs much better than one which are dull and dry. So making this medical subject also entertaining is what Akhand Vidyashram's prime objective is. Let's make it interesting. Give him something which is entertaining, and brain loves entertaining subjects. So I'm sure now you got something why depolarization happens the way it is happening. Now, although in this marked that it closed much door, but it does not. Sodium continues to go in till it reaches a supersaturated solution. No more sodium can go. The very moment sodium stops, instead of plus 30 millivolts, it is plus 35 millivolts. Now here again I'll bring something for you to really appreciate application of Divyank here. Between 55 to 0 is one spectrum, and 0 to 35 is the second spectrum. And the ratio of 55 into 35, interesting again, is Divyank. Is it my perception, or this is what this picture itself is telling? There are so many hidden things in this picture which I am trying to bring it out to make it entertaining for you. So it is plus 35, which is perfect, not 30. 70 fine, 55 fine, but 35 is better. When it comes to 35, no more sodium can get in, so sodium channels close and potassium channels open up. When potassium channels open up, that means potassium is going to get out of the cell. There is efflux of potassium. When potassium comes out, naturally the charge will start becoming negative again. And that from positive 35 to reducing it is called repolarization. Increasing called depolarization, reducing is called repolarization. But in this particular picture, old picture, voltage gated channels start to close at particular junction, they marked. But as a question which came to my mind, just by removing potassium from inside to out, and not to talk of the sodium at all, can you get a hyperpolarized state? Just not possible. With the limited amount of potassium is available. And I told you, for everything sodium which has gone in, only 2 can come out. And now only limited. So actually it cannot go to resting membrane protection or hyperpolarized. This is where I'm trying to bring in that sodium potassium ATP pump. So first potassium comes out. When potassium stops, there is no more potassium left. It cannot go out. That is the time when sodium is pushed out from inside and potassium gets inside once again. Because 3 have come out and 2 have gone in, charge comes down further. But since once sodium completely comes out and potassium goes in, you come to a stage of hyperpolarization. That means it's more than minus 70 millivolts, as you can see in this particular picture. When you come to the hyperpolarized state, how does it reach resting membrane potential was not at all explained in that particular thing. This is where I would like to bring my own understanding. It's a nature design. That means sodium has completely come out. Potassium as such, what is required, has gone in. Now you need little more sodium inside the neuron cell. And this influx of sodium from extracellular into the intracellular neurons is responsible for bringing it to resting membrane potential. And the scientific proof of that is presence of sodium inside the neuron cells in a normal state. You do not find it negative. And this is the sodium which had come out completely. Now is going in and proving why sodium is there. It is because sodium had to come because of hyperpolarized to resting membrane potential. So I'm sure at this particular juncture, this sequence of minus 70 millivolts, resting membrane potential, stimulus to threshold value of minus 55, then gated sodium channels opening up and fast sodium influx, steep depolarization, supersaturation state, sodium channel close, 35 millivolt charge, full. Then potassium opens, potassium comes out. Then bring in a sodium potassium pump to push sodium completely out, and then have potassium coming inside the cell once again, and that leading to hyperpolarized, and then sodium going in again to bring it to resting membrane potential. This particular event is all designed with Divyank, and as I plotted, that's why I call it divine nerve action potential. And I'm sure if this is understood, that no student would ever have, any intelligent student would have. People are used to only mugging and cramming and reproducing without applying their brain. I cannot say, because as far as I'm concerned, from my childhood, for the last 60 years, I've been very inquisitive, very intelligent, and questioning everything what I see, observe. Without a scientific understanding, I would not accept. And that also has to be with respect to conclusive mathematical design, and should also be in a position to convert it to symbolic representation consistent, which is not at all confusing. And from that point of view, I'm very happy that I have taken Nernst equation and show that it could be minus 61.834, and then talked about this particular thing in such a way so that entire world does have impeccable wisdom to build on. And this is the thing which I like everyone from school, college, and university understand it. It's not at all difficult, even young children, because I have explained this particular concept to my own very young children, and they really find it entertaining. And my desire is that the younger generation should have this kind of wisdom so that they don't have to unlearn and learn. New learning is very difficult. So from that point of view, I'm very happy that I applied my mind to understand how science works and what has been represented and why we should represent in a way which is impeccable in every way. From that, I'm very happy that I'm doing a good job, with the help of my voice of silence, which has given me extra understanding of nature, divine nature. And Divyank has helped me understand much better than I would have done this without mathematical design of Divyank ratio, Divyank sequence otherwise. With that, I come to the end of the stage and then say thank you very much. It was lovely sharing my spiritual experiences, my understanding of science, and my understanding of mathematics for the benefit of the world in the form of perfect human anatomy, physiology, biochemistry, and psychology, so that we can all lead a perfectly healthy, wealthy, wise, and happy. And like Ayurveda, theme of Akhand Vidyashram is that we should treat diet itself as medicine, not medicine. Without medicine, we should be able to prevent everything and lead a perfectly healthy life and curtail aging, even reverse aging, and that is the objective. And Divyank can definitely be a great asset for anyone to understand human anatomy, physiology, biochemistry, psychology, who wants to be productive throughout life and leave behind the legacy of impeccable wisdom. That way, thank you very much. It has been lovely. Thank you.